Hello dear students, welcome back to our class of discussion about the states of matter. In earlier classes we have discussed about the two states of matter, that is solids and liquids, and today we will discuss about another third state of matter, that is the gaseous state. So if we have a simple definition of gaseous state, the gases are defined as that state of matter which is having neither definite shape nor definite volume, right? So gases are something which are not having their own shape, not having their own volume. They take the shape and volume of the container in which these are kept. Whatever is the shape and size of the vessel, the given amount of gas takes the shape and size of that vessel, right? So why is it so? The reason is same, because in gas the interparticle distances are largest and the interparticle force of attractions are weakest. So the key property, the most important property of the gases which we have is they are having weakest interparticle force of attractions. Right? So in gaseous state, the interparticle force of attractions are weakest, and the another important property, which is because of course the first one, as the force of attraction between the particles are weakest, the particles are free to move in any dimension, in any direction, and that's why you have that gases have largest interparticle distances. Clear? Then another property of because of the same thing, the gases are highly compressible. Compressibility is maximum in case of gases, again because the distances between the particles are very large, so we can make them as close as possible, right? So that's why the particles of gases are highly compressible, and you can also have an activity to show the maximum compressibility of gases. You take some syringes, the same syringes that are used for giving injections to the patients. Remove the needle portion and block the pore of the syringe by using some rubber cork. So you take 3 syringes in which in all the 3 the needle part has been removed and the nozzle has been blocked by using a rubber cork, and in first syringe you leave it empty, you are not going to fill anything. In another syringe you have filled some amount of water, and in the third syringe fill some chalk pieces, right? So you take some chalk pieces and now put their pistons and try to push the pistons in by applying some force, in which case you could push the piston most easily. Of course you will observe the one which appeared to be empty, actually it was not empty, it was containing gas, that is air. So in this one the piston could be pushed in most easily. In water there was very small change, but in chalk pieces you could not do so that. So what does it show? It shows that gases are most compressible. Why they are most compressible? Because their interparticle distances are very large, so they can be made more closer, right? So compressibility is maximum in case of gases, then in water and or liquid, and least in case of solids. There are so many examples of compressed gases that we use in our daily life. For example, if we look at the compressibility of the gas, the most common example here is CNG. CNG, that stands for compressed natural gas, and this compressed natural gas is used as a fuel in vehicles and other appliances. And another one is LPG. It stands for liquefied petroleum gas that we use in our homes for cooking purposes. Another important application of liquefied or compressed gas is liquefied oxygen that is used in hospitals for providing artificial respiration to the patients, right? So these are the examples showing you the compressibility of the gas. You must have seen a balloon seller selling the inflated balloon and keeping a small gas cylinders. So these balloon sellers, they have small gas cylinders with them, and with this small cylinder, they inflate number of large balloons. How is that possible? Because gases are highly compressible, first thing, and another thing, gases do not have their volumes on their own. They can spread to as much space as much as available to them, right? So, that another very important and interesting property in case of gases is that the gases are very highly compressible, right? Another important feature of gases is that they are having lowest density. And why are they having lowest density? The answer you know very well, because of large interparticle distances. In a given volume of gas, the number of particles in that gas is very small. If number of particles is small, of course the mass is less. If mass is the less, volume is also less. Density is also less. So that's why the gases are having lowest density. Another property, because of their weakest interparticle force of attraction, the particles of gases are randomly moving, continuously moving, and because of that, the gases have property of diffusion. And this diffusion is again fastest in case of gases, right? If you take an unlit incense stick and keep it at one corner of the room, then in order to feel the aroma of that incense stick, you must have to go very close to the incense stick so that you can get the smell or aroma of that incense stick. But as soon as you lit on the incense stick, what happens? You can feel its fragrance even from another corner of the room and even from outside the room also. Why? As soon as you lit it on, what happens? The solid particles, they get converted to the gaseous particles, and these gaseous particles, they get mixed with air and diffuse to the larger spaces, right? Similarly, you must have experienced sometimes when your mama is cooking something very special for you in the kitchen, you can feel the smell of the your loving food from outside the kitchen, right? But if it is not something which is in gaseous state, like if it is ice cream or something like that, then in order to have the aroma of the food, or you cannot get the aroma of the food from outside, in that case you have to go in. So again it shows that gases are having very high rate of diffusion, right? And the reason is again same. Why gases are having fastest rate of diffusion? Because of very weak interparticle force of attraction so that the particles are free to move. And one more important property which you observe in case of gases is that the gases exert pressure on the walls of the vessel in which they are kept, right? What happens? Because of very weak interparticle force of attraction, these particles are randomly moving here and there, and during this random motion, they hit each other, they collide with each other, as well as they hit to the walls of container. When they hit to the walls of container, they exert some force on the walls of container, and that force per unit area is known as pressure, right? So gases have tendency of exerting pressure on the walls of container because of their random motion, and this random motion is again because of their weakest interparticle force of attraction, right? And this pressure is directly dependent on temperature. Higher is the temperature, higher is the pressure. Why is it so? Because you can see as the temperature increases, the kinetic energy of gaseous particles increases, and movement increases, and of course pressure increases, right? So higher is the temperature, more is the kinetic energy of the particles, faster will be their motion, more random will be their motion, and in that case they will be hitting strongly to the walls of container, and in that case the pressure will increase. So many examples you can see here. It is always advisable not to put your gas cylinders directly in sunlight. The reason is, when you put your gas cylinders directly in sunlight, then what happens? The particles of the gases, they absorb energy, heat energy from the sunlight, their kinetic energy increases, their movement increases, pressure increases, and what may happen? Your cylinder may burst. You can try the same activity at your home, the miniature one. You take an inflated balloon, put it in sunlight for some time, in bright sunlight for some time, and you will observe what happens? Right. After some time you will observe that balloon, boom, burst. Why it burst? Of course, same reason, because the air which you have filled inside the balloon, because of high temperature of sunlight, the particles are absorbing energy, and the pressure is increasing, and the time will come when balloon is unable to bear with this increased pressure, and in that case the balloon will burst, right? So these are some of the important properties of the gaseous state, that neither definite shape nor definite volume, weakest interparticle force of attraction, largest interparticle distances, highly compressible, least density, the rate of diffusion is fastest, and the gases have tendency of exerting pressure on the walls of container in which these are kept, right? So, if we compare the various properties of solids and liquids and gases, you will find the main reason behind the differences in properties of solids, liquids and gases is because of the arrangement of particles and because of the extent of interparticle force of attraction. In case of solids, the particles are compactly packed, almost no space between them, and the interparticle force of attraction in solids is strongest. The force of attraction is the strongest, the distance between the particles is least. That is the case of solid. If we talk about liquid, in liquid the particles are far apart as compared to that of solid with weaker interparticle force of attractions. That is the case of liquids. And if we talk about gases, in gas the particles are very far off with least interparticle force of attraction. The only difference between solid, liquid and gas which we apparently getting is the difference in the arrangement of particles. So is it possible that we can change this arrangement and convert solid to liquid or to gas, or vice versa? Yes, of course it is possible, and this interchange of a state of matter we'll be discussing in our next lecture. Goodbye till then. Have a nice time.